Hi, in this video I'm looking at doing this integral here of 2x times cos x dx. Now this is a product of two functions. We have 2x times cos x. Now when we're doing a derivative, we have a product rule for handling this. And we have an integration technique as well that goes along with this. And it's called integration by parts. And the integration by parts rule says that if I've got the integral of some function u times the derivative of another function v. So I've got v dash, which is the derivative of the original function v. Then it's going to be that function u times whatever that function v was, minus the integral of the derivative of u times by whatever that function v was, with respect to the same variable. So tackling this problem here, the first thing I'm going to do is take that constant 2 out the front so that it's not going to be in my way during my integral. So I've got x cos x that I want to integrate. So I need to pick which one's going to be u and which one's going to be v. And the way you do it is you need to pick whichever function is going to be the one that derives down to something that will eventually cancel out or become cancelled out when you integrate it. So we want something so that when it's derived, effectively is useless within an integral or has no effect on an integral. So I've got my two functions here. I've got x and I've got cos x. And I want to pick which one derives down to something that's practically not there. And well, if I think about cos integrates to sine. And so if I go and integrate that again, that's going to integrate back to a cos again, or a negative cos. So it's not going to help us because we're just going to end up in this cycle of cos sine, cos sine, cos sine if I keep trying to do this. So the best thing to pick is the x, because the x, when I derive it, becomes 1. And so it won't have any effect at all on this second integral. So let's have a look at doing that. I'm going to let my function u be x, and my derivative of my function v dash be cos x. And so now what I need to do is find what u dash is, the derivative of this, and what v is, the integral of this. So let's do u dash first. U dash, well, the derivative of x is 1. So that's easy. Now v is going to be the integral of cos x. So I've just got to integrate cos, which gives us sine x. So my v is going to be sine x. So now if I go and have a look at my integral, if I just look at my integral that I'm caring about as a whole, the integral of x times cos x dx is going to be, now I want to get u times v. So I've got to get u, which is my original x, times v, which is sine x. So I'm going to have x sine x. And then I've got to minus off the integral of u dash times v. U dash is 1. Multiply that by v, which is sine x dx. So I don't have to do any calculations here. This is just part of my answer now. So part of my answer is simply x sine x. I don't have to worry about that. But I do have to perform this internal integral here. So integrating this integral here, I've got the integral of, well, sine x, so I can ignore the 1. And sine integrates to negative cos. So I'm going to have negative cos x. And here, because I'm finally doing my integral, I'm going to add on the plus c, plus my constant. Let's tidy this up. So this is going to be x sine x. Two negatives here become plus cos x plus c. And so now just to finish this off, I had 2 times this integral. I've worked out what this integral is. It's x sine x cos x plus c. So now I'm going to times it by 2. So if I go back to my original, which is the 2 times the integral of x cos x dx, well, that's going to be 2 times by this that I've just worked out, x sine x plus cos x. And now I will just move that plus c out the end, because 2 times a constant is just a constant. So there we have the integral of this bit. So my final answer, really, because I wasn't working out this integral, I was working out this integral. So my integral of 2x cos x dx is, my final answer here, 2 outside of x sine x plus cos x plus a constant. And that's it. We are done. So that is our final answer. And to get there, we used our integration by parts rule, that if I have the integral of a function times the derivative of another function, v dash, then I have my u times whatever the original v was, minus the derivative of u times by the original v was. And the trick to using it is to pick u so that it derives down to nothing, so that it doesn't appear, or it doesn't have an effect on making this integral be a recursive pattern.